Good afternoon, ladies and gentlemen. My name is Sabrina. I'm a client-side GraphQL mobile frameworks developer at Meta. What that means is I'm very focused on client-side GraphQL and what I can do to help improve developer velocity and also performance for client-side users of GraphQL. I know many folks here have used Relay and are a little bit familiar with the connection specification, but today I want to pull the covers back a little bit. I want to talk about how we actually develop pagination frameworks from the ground up, not just for Relay, but for other GraphQL frameworks as well. So we're going to go through three things. Firstly, I want to actually talk through the connection specification. It's a little bit complicated, but I think once we derive how it starts, it lets us build really powerful pagination frameworks on the client. I also want to go through some of the pain points of pagination from the developer's perspective. What's tricky, and how can the connection specification actually help to make this better? And thirdly, client-side pagination framework surrounding it. So let's get started with the connection specification. So, pagination, what even is it? It's when you have some long list of data that you want to divide into pages that you can separately query. Say you have a long view that is scrollable. You want to be able to paginate and individually query for those pages. Excellent. So how do we start representing that in GraphQL? Well, the stupidest thing I can think of is a list, right? I've just got a list, and say I want to query for a set of my friends. Excellent. I've got the basis here. This can't paginate, but it at least gives us a starting point from the schema of what we can actually look up. Here I've written a query where I'm just going to query for my friends' names. But maybe I'm very, very popular and have lots of friends. Isn't it the dream? And so this isn't going to fit, right? We can't paginate on this in any form. So let's bump this up one notch, right? This is very simple index-based pagination. And for many pagination services, this is actually a completely reasonable way to do this, right? I have some index that I can paginate on, basically starting from 0, and I can ask, give me the first number of elements starting at this particular index onwards. You can see in my schema here, all I've really done is added this index and first value to tell me my count, and in my query, I've just added them here. Nice and simple, right? Unfortunately, this doesn't scale very well. For one, it's not particularly flexible, right? If I have indexes that are consistently changing as my data is mutated, or if I want to be able to paginate depending on different criterion, say ordering my friends by their birth dates or by their last names, this doesn't scale up well. And we're in GraphQL land. Things can mutate. Maybe I can make friends really, really quickly, or in between when I've executed my first load and I've scrolled through a list of friends. This is a very simple example, but you can see how index-based pagination can go wrong very quickly. Say I load 2 friends at a time, and the server has friend A, B, C, and D. Excellent, I've got my 2 friends loaded. But in between when I go to load my next page, a new friend gets added to the list. Well, when I go to paginate for my next page, we have a problem. I just got duplicate entries in my friend list, and that was just between these tail loads. This is problematic. It means that index-based pagination is not very robust against changes on the server. So let's bump this up a notch. What if we don't do pagination by index, but we have some sort of unique specifier or identifier that we can use to actually check our pagination state? And we get to version 3. Very similar. The only thing we've changed is on our friend, we've added something called a cursor. It's just some form of unique identifier that is opaque. It gives us more flexibility in our pagination and helps against the robustness of data changing. It's not perfect. Inevitably, as you're querying through some list, things can change, but we find it's more powerful than using index-based pagination. And more importantly, even if you want a simple system that is index-based, you can just make your cursor your index. It's your schema. You can do whatever you would like. And so we get to this particular point. But if you notice, I've had to add my cursor somewhere, right? I had a list of friends, and so, okay, I threw it on my friends object. But this identifier is not specific to my friend. It's specific to my pagination state. My friend really shouldn't need to be aware of it, and realistically, it shouldn't exist on their data model itself, because it's not about the friend. It's about the list they're within. But this is an easy fix. We can just add some intermediary object called an edge. And an edge just holds the ID and a node for my friend. Perfect. Now I have a pagination model where, as I query, all I have to do is just check for that cursor, grab the node, and grab the data on my friend I want. Perfect. Except what if I'm really, really, really popular, and I have lots and lots and lots of friends? These cursors start to get really expensive to generate. And if I go back to our query here, notice that I have to query for the cursor for every friend edge, right? But really, when we paginate, we're not particularly interested in the ID of every element. Remember, we only are interested in fetching after the last ID. Even if we're doing a tail load or a subsequent fetch of later data, or a frontwards pagination load where we're going backwards, we only need to know the cursors that are at the start and the end. And since these can be particularly expensive to compute, we want a system where we can just do it and know in that specific page we've queried for, what's the end of the data? What are we actually interested in? And before we come up with another schema with this, what if we want to add to that? In our current state, how do we know if we're actually done paginating? Well, the simple way in the existing state is we just do another query. And if we find no data comes back or less data than we requested, we're at the end. But that's kind of unfortunate, right? What if you're in a case where the exact amount of edges that you were fetching is divisible by your count? You'd have to do another fetch simply to discover, oh, I'm actually out. And that's costly if you have a lot of people accessing your endpoint at once, and it's useless. So let's modify our specification a little bit more. The only thing that's really changed here is I now have my edges, which contains the same cursor I talked about before and my node, but I've added something a little in here called page information. And what does that actually hold? It's exactly the info I just told you. It's, hey, what's at the back of this subset I've just fetched? And also, hey, can I keep fetching? Now, we don't have to query for every cursor every time we paginate. We've saved on that cost. And we don't have to execute an additional tail load just to figure out if we're done paginating. So this is awesome. We've done really well for ourselves, and we've come to, for folks who know it, the relay connection specification. And I want to be very explicitly clear. This does not need to be relay specific. In fact, I work on mobile GraphQL, which is inherently very scrollable and does not use relay because we don't use JavaScript in the mobile world. I actually work predominantly in C++-backed GraphQL pagination frameworks. This specification is very powerful. It gives us a mechanism that is robust against changes to mutations, that doesn't let us fetch additional expensive identifiers, that is flexible to changes as we change how we want to paginate, like by ordering, and also gives us a mechanism to still uniquely identify our nodes. Now, I've cheekily added something in here. I've slipped it in. We also support forwards pagination, and so the only difference here in our connection field is just we might have a before cursor and last, which means if we just want to paginate forwards, exactly what we talked about, exactly what it sounds like. Give me the last number of elements before this known cursor, or for forwards pagination, we say give me the first number of elements after this known cursor. Simple enough. And the page information, we also add something specific to forwards pagination, just like we mentioned earlier. We know our starting point, and can we forwards paginate? So great. We have a specification. We know this, Sabrina. We all use relay. Why do we actually care? Well, let's go through what it actually looks like to paginate on the client, and I think it will just drive how important using a formal specification is when we derive these points. So, I'm a product engineer, I have my list of friends, I have my specification, I am ready to start paginating. Awesome. Okay, so say I want to make some type of contact book, right? We have the friends paginating information we'd paginated through before, but even if this didn't follow the connection specification, we'd still have to write some similar query that accepts some form of either index or cursor and the number of elements I want. But look at the top. I have a fragment spread here for my view fragment. And that's because in practice, in production GraphQL, that paginable list is not going to be the only thing that I need to fetch specifically for my UI. I might want to fetch information about what the headers should say, descriptions. Maybe I'm using GraphQL to determine actually how I should even be rendering this and have the server let me know. So if I want to start executing tail loads or paginating, this query is now more expensive than I need it to be, right? I want to execute this only when I enter my initial view, but when I paginate, I don't want to have to re-execute this. I'm refetching information I already know from my view. And you say, that's easy. I'm a product engineer. The easiest thing to do is make a second query. Okay, great. We have our first query, which just does the first pagination fetch and gets us any information for our additional view. And then anytime that we want to paginate, all we have to do is use our pagination query. Excellent. And then, of course, as we continue to do our tail loads, or as users continue to scroll, we concatenate these lists together on the product. You say to me, this is still easy as a product engineer, and I agree with you. But remember, we need to keep track of the cursors that came back in our page information. So on the product, we also have to keep track of the cursors and have state management to know as the pages come in from head loads or tail loads, where are we actually changing these cursors? And you say to me, again, still very easy. And of course, because we're responsible UI developers, we want to notify people when things are loading. We want to be able to display loading spinners as the requests are in flight. And inevitably, if things are a little slower, we want to protect against users aggressively scrolling and continually re-executing the same tail load. So we want to be able to both update the UI frameworks to say, okay, please show me a loading spinner, and also make sure that we're not executing the same tail load request in flight multiple times. And then we want to be performant, right? Maybe I'm going to revisit the surface multiple times. You can imagine with my friends, a contact list is something that I'd keep revisiting to keep looking through my friends list. And so I want to be able to cache this in a certain way. And so as a product engineer, I now also have to build some caching mechanism. Sure, I can pull from different libraries, and whether it's a disk cache or a memory cache seems completely reasonable. I have to validate the data some way as it comes out from the cache, but all of this is reasonable. Except here's the problem. The mobile world is inherently scrollable. Every surface, whether it's a feed, a notification, a timeline, is scrolling. And if you want to power these services, mobile or not, through GraphQL, this is a lot of boilerplate. And what we found in production is this authoring of separate queries, keeping track of the cursors, updating the loading states, and just managing this growing list becomes a huge amount of code duplication, especially as you start to change implementations across caches, or you want to start using advanced incremental delivery directives in GraphQL. And this is where the power of the connection specification comes in. We, as an infrastructure team, can actually generalize this. And since we know exactly the names of the fields you're paginating on, that is your edges and your node, and we know the exact argument name you're taking in for your after, before, first, and last variables, we can start to automate this. So, for folks who've used Relay, I'm sure you've seen this before, but again, we've used this similarly on mobile, the @connection directive. This is used on a query in your query text, and you can think of it as basically a promise to say, hey, if I'm annotating this field with @connection, I promise that I am actually implementing the connection specification. When you annotate this in your query, one, we can run validation. We can make sure at compile time that you've actually properly implemented the connection specification, so our runtime framework can reasonably check for the nodes, edges, and page information field. We can also generate that refetch query for you. You no longer have to do the work to write that tail load query that just contains your pagination info, because we can look at your initial query, we know exactly what you're interested in, and we make our own under the hood separate query the product code doesn't even need to be aware of. And even better, we can plug this into runtime frameworks, which means products don't even have to know what page information, or better yet, what a cursor even is. We can dynamically change their query once they add this @connection directive to say, hey, we'll inject this page information for you, and we'll handle it for you on the client. This is very powerful, right? You can see right away, our initial query got significantly simpler. We no longer have the page information, and we don't have to write a secondary query. This is awesome, right? We've gone from so much code just to this one query right away, and we're going to start to simplify it even further. You can tell I'm an infrastructure engineer because I don't always have the cleanest UIs. But for any field labeled @connection, in addition to these guarantees that we have at the compile time, we can use a runtime state manager to look for the exact fields that you have in the connection specification. So this is a very simplified diagram. But importantly, this is a generalized framework that all connections can use, and no one needs to rewrite. You can see that the client executes some request, and it goes through a loading state service, a cursor service, and then to cache and/or network, depending if it's needed. Our loading state service can check if there are any pending requests in flight, reject ones that are already in flight, and also send a callback to tell the caller right away, hey, you're loading. You want to show a loading spinner here. And when the response comes back, we can simply mark the request as completed and send another update to the UI frameworks via a callback to say, hey, we're done loading. You can now display this information. The cursor service is also exactly as it sounds, right? As the requests are incoming, we know what cursors we can use because we have a state manager saving it for any field marked as @connection. And because we know that you are setting your cursors via the before and after query variables, depending on if you're forwards or backwards paginating, we can set these entirely in our infrastructure. Again, the product has no idea any of this is going on. All they have to do is tell us, hey, give me the next X pages, and we say, got it, and we handle everything for them. And when the request comes back in, we just update that last known start or end cursor depending on whether or not the data came back from the end of the list or the beginning. It also gives us complete control over caching and how requests are sent to network. We could completely bypass network if we know we have the implementation in cache. But we can also do even more with our cached implementations. So this is meant to be pseudocode. It is language agnostic because I really want to drive home that this isn't Relay and isn't JavaScript specific. You can do this in any paginable framework. But what this looks like from a product perspective is basically 3 functions, right? We have an execute initial load function that takes in some loading status callback and a response callback for when we have their pagination data, and load next and load previous page APIs to load the next page of information and previous. And you can imagine we then back some type of paginable list that's as simple as a list object of your edges and some identifier that you can use when you go to execute the next and previous page queries. So remember, we went from all of this. We went from having an initial query, a secondary written query, product concatenation logic, cursor management, loading state management, and caching to this. This is all the product developer needs to do. And this is entirely powered by the connection specification. We can only make frameworks like this because we know exactly what fields we're looking for. And when you annotate it with that connection, we can give our developers this guarantee that we can execute these requests on their behalf. Now the boilerplate is gone, right? Instead, we're in charge of that generic framework, which is very powerful for product engineers. They don't have to figure out caching or anything. We handle it for them, and they can write their UI views significantly faster. And we found this is really helpful for developer velocity. But here's the best part. We now own this infrastructure, which means we now have levers across the family of apps to try to find performance improvements specifically in this framework. That is, instead of experimentally testing on one surface, seeing if it works, and having to manually go change every single one, which I'm sure all of us have had to do at some point or another, we can do this all internally. So with caching, we can have custom caching policies. If you know that you want to disk cache, you can add a specification or configuration in your load next page or load previous page APIs to say use a disk cache. And the product doesn't have to know how that's implemented. We can handle it entirely for them and also validate the data that comes back with cache to make sure that it matches their new query in case they've changed it in between when it was cached. We can also handle in-memory caching. So we can store this data specifically in memory for them so that if they know they're only going to be consistently revisiting the surface in the same session, they can access it from memory and keep getting it back. We can also help make decisions on their behalf. Should we cache just the initial load? Should we cache all tail loads? Is there some balance in between? We can experiment and handle that completely in the infrastructure layer. And we can even let products have configurable time to live values. How old is acceptable for one surface might not necessarily be the same for another. So we can customize this. And again, we only get this at all because we have this shared connection specification that our connection directive has guaranteed they all follow. And for folks who follow open source GraphQL, I'm sure many of you are familiar with incremental delivery directives. We can even do this under the hood for pagination frameworks. For the uninitiated, these are relatively simple. Stream is exactly what it sounds like. You add it to some plural list, and instead of sending back the entirety of the list, we send back portions of it. You might say this seems antithetical if you're using pagination, right? You're declaratively announcing that you want each subsequent page. But we found that if you mix these paradigms, you can actually create something really powerful. You might want to load multiple pages that aren't necessarily immediately in view, but are very likely going to be scrolled to, so you want them streamed in, but don't want to pay the cost to have them delivered right away. We can use @stream on our connection edges, and we can actually apply this under the hood without the products knowing at the same time that we inject this page information into their query. Similarly, we can use defer. On what information? Well, if you're streaming in your edges, you don't need to know your end cursor right away because you can't yet continue paginating, you don't have all the data. So we can also defer the page information and say, hey, this is just metadata related to the connection. It doesn't handle what I'm actually viewing, so I don't need it right now. Under the hood, it looks something like this. We actually just apply the @stream directive directly on the edges and the defer label directly onto an inline fragment for the page information. And again, this is a powerful lever that we apply across connections. And it ends up looking something like this, right? We take all of this complexity and we bake it into a single load next page call. All that's changed here between this and the previous load next page call is a Boolean enable streaming, and what's my initial count? And if we have the Boolean true, we stream in the edges depending on their initial count, and we defer that page information. What I really want to drive home is that when we have powerful specifications like this, it lets us generalize infra solutions and also really improve both developer velocity and also performance. Just from having us share this specification, we're able to simplify product-facing queries, keep track of their current list, continually re-execute tail loads on their behalf, keep track of loading states and actually update the client engineers and vend them back for even tighter UI integrations, and also add advanced data delivery, performance, and caching for product engineers. Thank you so much for listening to my talk. I'm very happy to answer questions as well. Yeah. Go ahead. Yeah.
So what complexity do you need to consider when you have like this kind of centralized? So when these membership changes, what kind of complexities do you consider to centralize the cache management?
Quite a lot. Firstly, you have to handle, sometimes people also nest these pagination requests, which you can imagine get more complicated. You can imagine something like a reply to a comment gets nested. Do you cache those separately or together? That becomes complex. The actual caching mechanism itself is not too bad. You just have to make sure that you're keeping track of any changing query variables, and that's included in your cache keys so that you're not accidentally having cache hits for changing connections. But itself, it's not too complicated. As long as you key it specifically by some query identifier and also their variables, you're guaranteed that you basically have the same execution.
Can you have a factor like a change in one component can basically flush the cache for the other components?
Yeah, this is possible. We don't find it happens too much in practice, but it is possible. This is where having consistency can help because you can actually sync with your data manager and then update it back to the client after the cache read. Yeah. Yeah, so like the expensive part tends to be the cursors, right? Because that's the actual unique identifier that comes. And so that's why we optimize with the page information specifically. I mean, the nodes you can't get around because ultimately that is the data itself, right? The wrapper objects, computing those is extremely cheap, right? It's basically just creating a wrapper around that singular data you know for your connection. But what's under the node itself is just the data you need for pagination. Yeah, so we've encountered this. We've seen cases similar to replies where, yeah, you have a bunch of nested connections, and then what ends up happening is, as your connection responses come back and your tail loads come back, you consider those initial loads for the nested cases, right? Because now you have to start your state management again. What we have actually found is that it is better to not nest them, which seems counterintuitive based off of the data model, but for the exact reasons you've outlined, right? One, state management becomes much more convoluted. We're capable of doing it, and we have done it on the client in production before, but we also find that as things change, this model tends to fall apart more or less. What most folks do, for the most part, we only see nesting on the order of 2, is in like one main parent and then one main nested fragment. And so what we generally suggest in that case is just keeping them separate and having an identifier for your connection, and then using the connection specification, but not nesting it. So you have a separate query, you know that refetch ID from your first one, and keeping it separate. It just keeps the cache layers similar, and then it gets around the issue of, oh, well, I've cached both my parent and my sub connection, but now just the sub connection has changed. That way you can have a separate time to live value for the cached nested value, which is no longer nested. You can certainly follow the UX, right? I mean, it's a common way of building UIs. It's just in a GraphQL world, we found that trying to do client state management too many layers deep just falls apart. Yeah. I think it depends on how complicated your view is, right? Like one of the things I tried to say is that with index-based pagination, it's purely possible. And for most UIs, honestly, that is completely fine, right? If you know your data isn't significantly mutated, that is okay. Ultimately, when you're fetching for pagination, you are looking up the state of a list as it changes, right? So you are going to be subject to changes in any GraphQL pagination just by nature of having a time delay between when you're looking it up. But we found that the cursors are at least the most powerful way to try to get around that. So mostly for connections, oftentimes we'll see an extra parameter called order by, and we have the server enforce the ordering as opposed to the client. So what we can do then is for the tail load, we just know to append it at the end. For how to keep it sorted, I mean, it's really product dependent. Most of the time it is handled server side, but what products can do is take the paginable list we vended back, and it's their oyster. They can do whatever they want and sort it efficiently, however they feel best for their UI. Most of the time, though, we see, say you want to change like ordering on the client, they'll actually just do this separately on the server with some order by property.
Same thing with filtering. When you get
Yeah.
filtering and paginating.
Yeah, and actually what's nice is because the edge is pagination specific, if you want to do something like filtering, which doesn't affect my friend's data, right? You can actually add that information on the edge, right? Should I show, true or false? Has nothing to do with friend, but purely the pagination state. So you can add that onto your edge. It's kind of the nice part about having an intermediary object is you can just throw whatever pagination info you want on it. Awesome, thank you so much, guys.